Hello and welcome to Physics Basket. So we are going to discuss on topic 7 for class 9 foundation, and the topic is acceleration. So let's get started. So let us start with acceleration. Before we start with acceleration, let us revise the previous fundamentals. We have already understood that what is velocity. Velocity is basically the change in displacement by per unit of time. So delta D by delta T we can call. So this is what is the velocity that we have understood earlier. But an object moving with a certain velocity, does it necessarily mean that the velocity is going to be constant forever? No, basically the velocity may change. A very ideal example can be if we take basically a velocity and time graph, then a train normally starts at the point of observation initial time. When the time is 0, the train starts with a velocity 0, then and it goes to a final velocity say v, and then it continues in that velocity for some point of time before it again going down and then finally stopping at a station. That means the velocity is decreasing from the final velocity to a initial velocity, the acquired velocity, to a final velocity of 0 again. That means it's coming to a stop. So velocity is changing continuously. This point is the change in velocity. This point the velocity remains constant, and this phase the velocity is again changing. So these are the three different phases in which the train is moving. So this is what an object can basically change its velocity in the due course of time, and the rate of change, the rate at which the velocity changes with respect to time, is nothing but the acceleration. So delta d by delta t is v, whereas we can say delta v means change in velocity by delta t, the change in time, is called the acceleration. So same familiar example, let the train start with initial velocity and then it goes to a final velocity t, and then it acquires and it takes a time t. So in this case, since it is starting with initial velocity of 0 and it acquires final velocity v and time is t, so coming back to this, then acceleration is basically delta v by delta t, nothing but a change in velocity by change in time. Change in velocity is what? V minus u. V is the always final velocity. Normally we denote the final velocity by V, and the initial velocity is denoted by small u, and then the total time taken to change for this change is basically t. So this is what we get an equation, A equal to V minus u by t, right? And this is the equation basically, A equal to V minus u by t, or V equal to u plus at. So of course in this case the initial velocity is 0, then so just replace u equal to 0, then you will get v equal to at or a equal to v by t, wherein the initial velocity is 0. But in some window, you may not always have u equal to 0. Basically, when your observation is in a course of time, like you're starting an observation time from here and it's reaching here, that means the t equal to at t equal to 0, when the observation starts, the velocity is already 15 meter per second. So it is, say, example, it is 15 meter per second when t equal to 0, and then it goes to 20 meter per second at t equal to 2. That means that it has taken 2 seconds to accelerate from initial velocity 15 meter per second, which is of course not 0, to final velocity of 20 meter per second. So you can simply say the final velocity minus initial velocity is your delta v, change in velocity, divided by the time taken, delta t is 2. So that means that 15 minus 20 minus 15 is 5 by 2 is 2.5 meter per second square is your velocity. So in this case, So the observation time, at the time of observation, if the velocity is not zero, then this particular u is also not zero, and you can calculate the final velocity or acceleration accordingly. Again, point to be noted is acceleration is a vector because it is associated with velocity, and velocity is always associated with some direction. So acceleration is also a vector quantity, and its unit is meter per second square. How do we get it? Delta v by delta t. So delta v by delta t is change in velocity by change in time. Change in velocity is meter per second, and change in time is again second only. So meter per second square. So meter per second square is the unit of acceleration. So starting with acceleration again. So acceleration itself may be uniform or non-uniform, right? So means that the rate at which an object can accelerate may be always constant. That means it is always accelerating at a constant rate, or it may be non-uniform. Let us just try to understand with some sort of an example. Like a train starts from a station, it requires a velocity of 5 meter per second in t equal to 1 second, and its velocity increases by 5 meter per second every second. So every second it is increasing by 5 meter per second. So first initial velocity is 0. At t equal to 1, the velocity has become 5 meter per second, and every subsequent second the velocity is increasing by 5 meter per second. So let us see this table. At t equal to 0, the velocity is 0. At t equal to 1, the velocity has become 5. At t equal to 2, the velocity has become 10. At t equal to 3, the velocity has become 15. At t equal to 4, the velocity has become 20. So these are the acceleration. If you just try to calculate also with your acceleration formula, so between this to this time frame it is 5 meter per second square. Between this to this time frame also it is 10 minus 0 by 2, total time taken as 2, so it is 5 meter per second square. Or between this to this time frame, basically between this to this time frame also it is 5 meter per second. So every subsequent time frame the acceleration is 5 meter per second square, which means that it is actually going or accelerating with a constant acceleration. So it's a constant or a uniform acceleration. Let us see an example wherein the acceleration is not constant. Initially the velocity is 0 at time equal to 0, then at t equal to 1 the velocity is 5 meter per second. At t equal to 2, velocity becomes 12 meter per second. At t equal to 3, velocity becomes 20. At t equal to 4, velocity becomes 25. So for each of this interval, this interval, this interval, and this interval, we need to calculate. So what is the time? The delta t is same. Every subsequent second, the t is 1 second, but the velocity is in the first frame it has increased by 5 meter per second. For the second time frame, second, it has increased by 7 meter per second. 12 minus 5 divided by 2 minus 1, right? So it is 7 meter per second. Similarly, between the third time frame, which means that v minus u, v is in this case v is 20, u is 12, so v minus u is 8 divided by delta t. Delta t is always 1, so we get 8 meter per second. So in this case we are seeing that there are different acceleration at different time frames, so which means that the acceleration is non-uniform. So these are the examples of how a uniform and non-uniform acceleration can be. So looking at the table for the constant acceleration, we had 5 meter per second square, 5 meter per second square for every time frame, right? So from the table, as we get to know, at t equal to 1, that is what the same thing, we get 5 meter per second square, because 5 minus 0, 5 minus 0, this is the 5, this is the previous velocity is 0, divided by total time is 1. Similarly, at t equal to 2, again it's so, and so on. So that's the reason this is the constant. So this brings us to the end of this topic, and the upcoming topic we will discuss the topic 8, class 9 foundation, and the topic is distance and time graph. Till then, thank you for being here. Keep subscribed for further information on the upcoming topics.